All right. So as we were saying, yes. So that is the formula for the prismatic section, and this is also the formula for the non-prismatic section, as we were saying. Okay. So these two together forms the lecture 4. These are the formulas we learned from the lecture 4. Exactly. Exactly. So let's just quickly pick our calculators at this point and let's begin to solve some examples. At this point, we only pick one examples from here, and so but the rest we'll be going to solve most of the trial questions on our own. So let's take note of that. Problem 4.1, because we are in what? Lecture 4. And the one means we are in example 1 of lecture 4. I want someone to quickly read this question for me loudly and let's proceed. So the question says that a rod which tapers uniformly from 40 millimeter diameter to 20 millimeter diameter in length of 400 mm is subjected to axial load of 500 Newton. If E is 2.1 times 10 exponent 5 Newton per millimeter squared, find the extension of the rod. In other words, find the change in length of the rod. In other words, find the deformation of the rod. In other words, find the elongation of the rod. Good. So I want someone to take this question for me one last more time again, even before we proceed. Any volunteer to read this question for us before we proceed?
Yeah.
Yes, very good. Before that,
A rod.
proceed.
A rod which tapers uniformly from 40 millimeter diameter to 20 millimeter diameter in a length of 400 millimeter is subjected to a axial load of 5,000 Newton if E equals 2.1 times 10 raised to the power 5 Newton per mm square. Find the elongation of the rod or extension of the rod.
Thank you. Thank you very much. That was very, very wonderful. Everyone, let's give him a reaction. Let's give him a reaction. All right. That's so wonderful. So I want to ask a question even before we proceed. Which kind of tapering bar is this? Is this a uniformly tapering rectangular section or a uniformly tapering circular section? Can anyone
It's
bring
a
up?
uniformly tapered circular section because of the diameter.
Thank
It indicates it's a circular section.
thank you. Thank you very much. That was so wonderful. That was so wonderful by answer. Everyone, let's give him a reaction. Let's give him a reaction. Let's give him a reaction. All right. So that was a very wonderful contribution. And the answer was just perfect and correct. Due to the presence of the diameter, if we were hearing with, we will know that it is a rectangular one. So we're going to use the rectangular formula. But because we are hearing the word diameter, it means we are going to use the formula that has what? Pi in it. You see, it means we are going to use the formula that has pi in it. So a smart student, once you even saw the diameter first of all, you come and put over here your change in length. The formula to calculate for your change in length in this kind of question is going to be what? 4PL. 4PL. 4PL over pi times E multiplying D1, D1, D2. Good. Good. Moses, Safo want to ask a question. Please kindly unmute yourself and ask a question.
Please, my question is that the diameter and the thickness, is it that the only difference that we have in the circular sections and the rectangular sections?
Yes, because at the end of the formula that we have used to calculate for the, let me say, the area of this would have been different from the formula that we used to calculate for the area of this two. Do you realize? Uh-huh.
Yes.
So the pi is actually coming from the what? Circumference. Okay. It's due to the circumference of the circle that is bringing about the pi.
So as soon as you don't see a diameter in a question, does that mean it's a rectangular section?
If you don't hear that, in this case, for this case or for this course, if you don't hear diameter, consider it to be a what? A rectangular section. Okay. But always pay attention to the question, because if they don't bring diameter, they can bring what? Radius. If they don't bring a diameter, they can bring a what? A radius, which you have to be smart to multiply the radius by 2 to get the diameter. Okay. So the whole of this is a diameter, but a half of it would have been a what? A radius.
Radius.
Intelligence is being able to adapt to changes. When the drum beat changes, you should also be able to adopt the dance. Exactly. All right, let's proceed. So we are saying that, please, are you okay?
Yes, please, I'm okay.
So we are saying that a rod which tapers uniformly from 40 diameter. So you see, my last question before we proceed, the 40 and the 20 which one is going to be D1 and which one is going to be D2?
Please, D1 is going to be 40 mm and D2 is going to be 20 mm.
Thank you very much. And why? Can you give me a reason to your answer?
Okay. Okay, because D1 is having a greater diameter than the D2. So the circular section, one side is bigger than the other. That's it.
That was a very, very wonderful contribution given by Esther. Everyone, let's give him a reaction. Let's give him a reaction. Let's give him a reaction. That was so wonderful. And that was just a very, very perfect answer. Okay, exactly. So our question says that a rod which tapers uniformly from 40 diameter. So it means that the D1 is going to be hot, the bigger one. So 40 diameter to what? 20 diameter. So our D2 is equal to 20 diameter. Exactly. In length of 400 Okay. So let's quickly put the length over here. Our length is equal to 400 400 Exactly. It's subjected to an axial load P. So you see our axial load P is equal to what? 500 Newton. Now, what can we also see? We can now see that our elasticity, E, is being given as 2.1 times 10 exponent 5. Okay, that is Newton per millimeter squared. Don't get confused if I write my per millimeter squared like this. It's all the same way. Now we are being asked to find the extension, the total extension occurring in the bar. So if you are being asked to calculate for the extension, that is the change in length, which you don't know, what are you going to do? You just adopt the use of this formula. Everyone, let's quickly substitute all of this you are seeing over here into the formula and tell me the answer. By substitution, quickly substitute all of this into the formula and tell me the answers you are getting. Everyone should partake in this and tell me the final answer. Before we move to solve our second question, everyone should partake in this. Quick. Okay, I know what to do. So let's all punch. That is 4 times 5,000, or 4 times 5 kilo, all over 22/7, which is also known as the pi. If you can't see pi on your calculator too, it is a problem. Okay, yes. Times 2.1 times 2.1 times 2.1 multiplying 10 exponent 5 times 40 times 20. Okay. So please, what is the answer you are getting? I just finished doing mine. Which answer are you getting? Hello. I can see some answers in the comment section, but I'm failing to accept them due to some one or reason, two reasons. Quickly correct them before I make comments about them. Any answer that is mentioned with a wrong unit is actually wrong. Okay? Yes. Please, which answer are you getting? Kindly unmute yourself and make us history. Kindly unmute yourself and speak to us. All right, all right, all right. So, Simon Peter, Simon and Patricia had, let me say, 0.015 millimeters. Okay, and that is just so wonderful. An answer without a unit, an answer without a unit is always classified as wrong because we don't know what you are talking about. Okay, we don't know what you are talking about. So your answer is supposed to be denoted as this. That is what? 0 0.0 0.015 0.015. If you like, you can leave your answer in even 4 decimal places. Okay, so let's say 0.0152 millimeters. Okay, because it is just a change in length. Okay, so you have to also leave your answer as that. Change in length, change. We are still talking about length, so you don't think too far. Okay, don't think too far. All right, all right, all right. So that is it for our first one. Is anyone encountering any challenges? Is anyone encountering any challenges he or she wishes we all address together? Hello, please don't feel free and ask your question. Let's address it all together before we proceed. Is anyone facing any challenges? I feel like helping everyone and making life much more easy for everybody. Okay, let me show you something. Someone just text me a message and I want to address something. Okay, we are solving problem what 4.1. That is problem 4.1. That is we are in lecture 1 and we are solving what example 1. Okay, so what is actually happening over there is that we say we are using a formula such as our total change in length in the bar is going to be calculating using a formula of what 4PL all over what pi all over what the pi multiplying e, okay, times d1 d2. If you see dot, it just means multiplication. Okay, don't get confused. Okay, take note that in the course of writing this, if you can't find pi in your calculator, this pi over here, this very guy, if you can't find pi in your calculator, you can just point 22/7. Okay, because pi is equal to 22/7 and you still get the same answer. Intelligence is being able to adapt to changes. If the drum beat changes, adapt the dance. Okay, that is why I'm saying don't feel scared to ask your question. Ask your question because the question you are afraid to ask, it has a solution to, or whatever problem you are facing in life, it has a solution. Okay, so 22/7. If you can't see pi in your calculator, you can use 22/7 because pi is the same as 22/7. Okay, times your elasticity. Okay, times d1 times what d2. Okay, so let me finalize everything by telling you that note that pi is equal to what 22/7. Note, and that is the note I want everyone, each and everyone should write somewhere today. I'll ask you one day in the future. The pi is equal to what 22/7. Yes, 22/7. So if you ever find yourself in any uncomfortable situation in an examination, you can't see the pi, you just put 22/7 over there, but just remember to put it into brackets. Okay, so that whatever you are doing at the end of the day, you can still be what precise. So whatever we were punching over there, you can now come and punch it this way and see whether you will get the answer we are getting or not. If you don't get it, let us know so that we all do it together. Okay. Yes. Always remember to write your given before you solve your work. If you don't write the given, you will be penalized. Very, 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 very well. Or you will lose marks. You will lose marks. Okay. So in this case, the 4 is a constant and our length. So we say that what? 4 times, look at the formula. 4 times our what? Load times the length. So let's go and do it together. 4 times the load, which is what? 500, 5,000 or 5 kilo. Okay. The length was 400 millimeters. All over what? Come and see. All over the pi. In this case, we want to use 22/7. Okay. Multiplying E, D1, D2. So let's go. So multiplying the pi. So you're going to put 22/7 over there. 22/7. Okay, good. Multiplying our E, and we said our E is equal to 2.1 times 10 exponent 5. Okay. Times the diameter. The diameter one is, let's say, 40, and the other one is what, 20. So times 20 times 40. Everyone, let's quickly do this together and tell me the answer you are getting direct before we mention the final answer. After punching this, what are you getting? After punching this, what are you getting? I had 1/66. I'm getting 1/66. Okay. 1/66 millimeters. And 1/66 millimeters, if you re-punch it well again, what are you going to get? Everyone, quickly punch this together in the calculator and give me a feedback. 1/66, what are you going to get? 1/66, 1/66, what are you going to get for your total change in length? So the 1/66 is the same as what? 0.0115. Okay. We can just end it here. 2 what? Millimeters. Okay. As simple as that. On this note, I continue to say that what? The laws of physics are the same for all observers in uniform motion relative to one another. Okay. So if you don't want to see the pi, you can't see the pi. And if you don't want to use the pi, you can't see the pi in your calculator, you can use it this way. Exactly. I want to take some few questions before we proceed. So that is Patricia had the answer, Moses had the answer, Ansa also had the answer, and that was just so wonderful. Okay, let's solve our problem 4.2. Let's quickly solve our problem. So let's quickly solve our problem 4.2 and let's proceed. Let's see how this question look like. Problem 4.2. Can anyone read the question for us? Any volunteer? Okay. So the question is that a rectangular, oh, this one is too straightforward. A rectangular bar made of steel is 2.8 meter long. A rectangular bar made of steel is 2.8 meter long and 15 mm thick. The rod is subjected to an axial tensile load of 40 kilonewtons. The width of the rod varies from 75 millimeters at one end to 30 millimeters at the other end. Find the extension of the rod if E is equal to, let me say, 2 times 10 exponent 5 Newton per millimeter squared. Okay, yeah, so that is the question. Let's quickly put down our given and see how best we can become history. So let's just write the given somewhere here. before that, I want someone to read a question for us. Anyone, any volunteer to read a question for us? Okay. Yes. Patricia,
A rectangular. Okay.
Patricia, I can see your hand up. So kindly unmute yourself and then read a question to us.
Okay. A rectangular bar made of steel is 2.8 meters long and 50 millimeter thick. The rod is subjected to an axial tensile load of 40 kilonewton. The width of the rod varies from 75 millimeters at one end to 30 millimeters at the other. Find the extension of the rod if E is equal to 2 times 10 raised to the power 5 Newton per millimeter square.
Okay. Thank you very much. Yeah. So you see, this question is also very, very, very straightforward. Okay. For this question there, you know that it is because it's a rectangular bar, so it's just straight. So that is, we are going to adapt the use of this formula. Okay. So for our change in length this time, what are we going to? We are going to use the formula of the formula known as 4p as what PL. This time it's no more 4PL. So you see our change in length. We're going to be using this formula. Okay. So that is PL over E multiplying the T, okay, times the difference in what width, A minus B, okay, or multiplying the log E, or multiplying log E, or multiplying log E. You open a bracket, that is what? You bring A over what?
E over B. Bracket close.
Exactly. So this is how you are supposed to do this on the calculator, as simple as ABC. Okay. So let's just this time let's go and work systematically. Let's go to our black whiteboard and then let's start from the given. So in this time we are solving for, let me say, problem 4.2. So this is problem, and for problem 4.2, what can we say? Let's start from our given. Okay. So the question says that a rectangular bar made of steel is 2.8 meter long. So the length is equal to 2.8 meter. And what is going to be this dimension in millimeters? We just have to multiply it by 10 exponent 3, right? So it's going to be 2. Let's all do it together. 2.8 times 10 exponent 3. What are you going to get? You're going to get 2,800.
2,800.
2,800 millimeters. Good. Then from there, they say that and 15 millimeter thick. So the thickness of the bar. So thickness, the thickness which is equal to, so taking that the whole of this is just equal to the L. And then the thickness which is equal to the T is equal to 15 millimeters. Also, the rod is subjected to an axial tensile load. It's a tensile load, okay, 40 kilonewton. So we said that tensile load, the tensile load is equal to 40 kilonewton. So 40 kilonewton, which is the same as 40 times 10 exponent 3. 40 times 10 exponent 3 Newton. Let's proceed. The width of the rod varies from 75 at one end to 30 at the other end. So you should know that this always A is the bigger one. Okay, always A is going to be the bigger one. So take note. So A is equal to 75. So width at bigger end, let me say width, the width at bigger end, width at bigger end, width at bigger end, that is A, is equal to 75 millimeters. 75 millimeters. And also we say that the width at smaller end, the width at smaller end, B, which is also known as the B, okay, is equal to 30 millimeters. 30 millimeters. Okay, exactly. So let's proceed. And the elasticity. At the other end, find the extension of the rod if elasticity is equal to this. So the extension of the rod, we don't know. Extension is this. The extension of the rod is what we are being asked to calculate for, which we don't know. So the extension of the rod is the change in length, which we don't know. We can call it the total change in length of the rod, which we don't know. So finally, what can we say? The elasticity. Okay. The elasticity E. Elasticity. Elasticity, which is the E, is now equal to 2.1, or let's say 2 times 10 exponent 5. Okay. 2 times 10 exponent 5 Newton per millimeter squared. Newton per millimeter squared. Okay. So finally, we can just move to our solution, quote our formula, and then we proceed. So this is our solution. The formula we say we are going to be using. Let's all adopt that formula and punch it into it, and let's proceed. Okay. So we say we are going to be using this formula. That is our change in length. It's going to be equal to PL over the E multiplying T, okay, times the difference in width, A minus B, okay, all multiplying log E, all multiplying log E, all multiplying log E, log E over A over what? B. So everyone, let's quickly point this together. Let's all point this together and see how best we can all become history. Let's all point this together. So the P, we already know what the P is, and the P was given as 40. The P was given as 40 kilonewtons. So we say 40 times 10 exponent 3. So 40 times 10 exponent 3 times the length. Okay, and the length is given as what? 2,800, as we all converted. 2,800. Okay, yes. All over the elasticity. We said that elasticity is equal to 2 times 10 exponent 5. Okay, times the thickness. The thickness was given as 15. If you can see, this is the thickness over here. So we put it over there, 15. Multiplying the difference in width. So A was 75 minus B. And B, what was the value of B? What was the value of B? B was 30. Okay, 30. The width at the smaller end, it was 30. So minus 30. Exactly. All of this now is going to multiply log e. Okay. Log to the base e. You see. Okay. Multiplying what? 75. 75 over 30. So everybody, please let's all do this together. Let's all point this together and tell me the answer. In few minutes time, the link is going to be off, and that will be all. So 40 times 10 exponents 3, okay, times 2,800 all over 2 times 10 exponents 5. Okay, let's all point together, times 15. Someone is already done. I can see someone's reaction in the comment section. Failure to add units or the appropriate unit to the answers will cause you to be penalized or will cause your answers to be wrong. So remember to do that. Let's all point that together. In a few minutes, I'm going to confirm the answer. Yes. So I urge each and every one of us to learn how to use the calculator. Okay, to learn how to use the calculator so that at the end of the day, life can become much more easier. Your ability to be able to use the calculator very well will also depend on how you know how to use the PC very well, because psychologically they are all the same thing. Yes. So finally, I'm getting. Let me check the comment section. I can see some few people getting the answers. That is Patricia had the answer, Daniel had the answer, Esther also had the answer. Exactly. So you are supposed to be getting what? You are supposed to be getting your total change in length of the bar. Okay. Yes. To be equal to 0.7601 8. These are the answers you are supposed to be getting. At the end of the day, I'll write the final answer. 19405. You see. So if you are not getting these answers on your calculator, then you should punch it well again. Okay. So finally, we can say that therefore our total change in length of the bar. Okay. So therefore we can say that our total change in length of the bar is equal to what? 0.7602 millimeters. Okay. Millimeters. So this is the answer you are supposed to be getting. Okay. A good Samaritan should put a camera on his calculator. Okay. And whilst he's typing the thing, he should put it on the page so that at the end of the day, your colleagues can also benefit from being able to punch it. Okay. Yes. Very good. On this note, my name still remains Megabyte the physicist. Don't hesitate to see me in groups, in person, one-on-one, in case you encounter any challenges in understanding some of the concepts and the techniques that is being adapted in being able to solve some of these questions. Good students should do well to like the video, subscribe to the channel, so that anytime that I drop a video, they can be able to get a feedback, because it's not all the videos that are uploaded on the site that I will let you know that I have been uploaded. Thank you very much for your time once again. Have a very wonderful day. Don't forget to continue reading and continue practice, as practice will always make you perfect. Even footballers, when they are going, before they go